Hi students, I am Sri Ramchandra, Faculty of Computer Science Engineering. Today I would like to discuss binary tree and its traversals. Before going to discuss its traversals, let me discuss the definition of binary tree first of all. Hope you are familiar with degree of a tree. Hope you are familiar, all are familiar with the word degree of a tree. Means the number of children nodes associated with that particular root node is called degree of a tree. For example, and if this is the tree, node A is having degree 2 and node B is having degree 0, C is also having degree 0. Finally, we can say that degree of a tree is 2. Like this, and if the degree of a tree is either 0 or 1 or 2, then obviously we can say that it is a binary tree. Or in other words, we can say that the tree in which each and every node have at most 2 children is called a binary tree. Now, coming to its traversals, there are 3 types of traversals. First one, pre-order. Next one, in order. Next one, post order. Next one, post order. In general, binary means the basic structure of a tree is considered as this thing. The basic structure of a tree is being considered as this thing, in which I can call it as root part and I can call it as left child node and it as right child node. And coming to its denotions, let it be small r, let it be capital L, let it be capital R. Now, based on these positions, we are having pre-order, in-order and post-order. Coming to the word pre-order, placing the root node in front of left child and right child is called pre-order. In-order means placing root node in between left child and right child. Post-order means placing root node after left child and right child. This is the thing how you can write in-order, pre-order and post-order. Now let me explain with an example now. Now here, consider this as a binary tree, and now I would like to write pre-order, in-order and post-order here. Simply, this is the order of sequence which you are supposed to consider in writing pre-order with a little bit condition here. What is the condition here means? Whenever you identify root in any order, start the sequence from the initial state. For example, if you are going to write pre-order and identified root, consider this process, root left and right. And whereas in order, even you have identified root node, start from left root and right. Post order, here also, if you identify any root node, start the process as left, right and root. If you didn't understand, you please don't bother. You can have a clear idea when the example is over. Now consider pre-order. Now consider pre-order. The basic structure of order is root, left, right. The order itself indicates, first of all, you are supposed to visit root node, and then left node, and then right node. Here, not only left node, entire left part also. Here, and not only right node, entire right part also. First of all, visit the node A. Yes, it is a root node. Next, immediately you are supposed to go towards left part. Yes, again it is a root node. What I said in the condition, if you find any root node, please start the sequence again. Means you are supposed to move towards left one. After B, you are supposed to move towards left one. That is, here again, it is not a root node to anyone. So just stop the sequence and go back. And for this tree, you have visited the root node and left part. The remaining is the right part. Right? And for the entire tree, you have visited root node and left part. Now you are supposed to go for right part. And again it is a root node. Just simply write the root node and then go for left node. And it is not a root node for any children. Simply write this thing and then come to right. So this is the way how you are supposed to write pre-order. And now consider the procedure to write in order. What is in order? Left, root, right. Here, first of all, you are supposed to visit left node. But in case if you find root node as a starting node, then go to left immediately and repeat the process until you reach the last left. So this is the basic definition of the condition which I have discussed earlier. First of all, you are supposed to visit left, but I have visited root node. As I said, if you visit root node, simply go towards left one, and again it is a root node, simply go towards left one, and this is not a root node, simply write that left node here. And after visiting left node, you are supposed to write root node, that is B. And after visiting left and root node, you are supposed to visit right part, that is E. Now for the entire tree, left part has been completed. After completing left part, you are supposed to go towards root part, that is A. And immediately you are supposed to go towards right part, that is C. And again it is root node, simply go towards left one. And then root, and then right, and for the entire tree you have completed left part, root part and right part. This is the way how to write in order. Now the last but not least order, that is post order. Simply it is left, right, root. As I said earlier, if you find root, start the sequence. The same condition works for the entire three orders or the three traversals, what you call. And here I have visited a root node initially. What it says, you are supposed to go towards left. Yes, I have come towards left. And again it is a root node. What it is saying? Move towards left. Yes, I have moved towards left. And again, here it is a root node or not? No, it is not a root node. Means just stop that and write D here. Immediately after visiting left part, you are supposed to visit right part. That is E. Okay. Immediately after visiting right part, you are supposed to visit root part. That is B. Now for the entire tree, we have visited left part and we need to go towards right part. Here that is C, and again it is a root node. So immediately you are supposed to move towards left one, that is F, and immediately you are supposed to move towards right one, that is G, and immediately you are supposed to move towards root node, that is C. Now for the entire tree, left completed, right completed. The remaining is root node, that is A. This is the way how to write post-order traversal, in-order traversal and pre-order traversal. Yes. Before going to conclude this traversals, let me check the orders are right or not. Means by using in-order and pre-order or in-order and post-order, I can reconstruct the tree back. Let me discuss that also. For example, post-order, left, right root, that is D, E, B, F, G, C, A, and in order, left root right, that is D, B, E, A, F, C, G. Okay. Now our task is to reconstruct the tree back by using these two orders. Simply, we can say that the last visited node should be the or must be the root node. Why? Because we are going to follow the sequence and for the entire tree. Simply we can say that A is the root node. Simply we can say that A is the root node. Yes. Absolutely A is the root node. Okay. Now check the position of root node in order. Means the elements which are left to the root node are left child nodes. The elements which are right to the root node are right child nodes. Simply DBE comes under left part and FCG comes under right part. And then just discard A. Now find the sequence or find the elements DBE in post order to identify which element must be the root node. See, D is there, E is there and B is there. In between or among these three things, the last visited is B. Surely we can say that B is the root node among D, B, E. Okay? And now comparing the element D, B, E in order means B is the root node and the element left to that B is called left child node and the element right to that root node is called right child node. Simply we can say that D is left child of B and E is right child of B. The same diagram can be transformed as this is B, this is D and this is E and again F, C, G. Okay, now we can strike off these things here. Now again, And again, this is also useless part now, as we have constructed nodes from this sequence. Now our task is to find left child, root node and right child among FCG. For that, identify the elements here. Yes, FGC. FGC. Obviously, the last visited node is C, and this might be the root node, or this must be the root node. Simply, the diagram can be transformed as like this. And then comparing the left part of C, that is F, should be the left child, and the right part of the C, that is G, is the right child of a tree. So this is the way how to reconstruct back the binary tree using post order and in order. Not only these two orders, by using pre-order and in order also, we can construct the binary tree back. Why? Because, or how? Because the pre-order itself gives the starting node as a root node, and in order gives the information about left part and right part. Simply we can construct a tree. Then what about only in order? Can we reconstruct a tree, binary tree back only using in order? It is somehow difficult. Okay? If at all you want to construct the binary tree using only in order, you need to study the properties of the binary tree. Means if it is a full binary tree, then we can construct the binary tree back using only in order. But there may be a chance of non-unique binary trees by using in order. Thank you, friends.